Today I'm going to show you a tool that I just built called a hot wire foam cutter. Now, some of you might be familiar with the term, but for those of you who aren't, a hot wire foam cutter, simply put, is a piece of high resistance wire under tension that gets heated up with electricity, and it allows you to melt through a piece of styrofoam. Now, okay, so what's the point of doing that? Well, styrofoam has hundreds of different uses. I mean, it's one of the most versatile, easy to work with building materials there is. It's not super strong, but its strength to weight ratio is excellent, so it gets used in aircraft quite a bit. And that's one of the biggest uses beside residential construction would be in aircraft construction. It's so easy to form, it's easy to sand, it's easy to get the contours in you need, and it's also very light, of course, is what you need in an aircraft. So you can put fiberglass over it, carbon, Kevlar, and make a super strong structure. And some of the most high-performance aircraft, civilian aircraft, are based on this composite technology of fiberglass over foam. Also, foam can be used to make molds. Like if you're doing sand casting, you can easily make the patterns for sand casting. You can also use it to make props for a set you might be working on. Like I said, there's all kinds of uses, and one of the very important tools of cutting foam is having a hot wire foam cutter. So as you can see, most everything on here is ordinary hardware store components. You got the extension spring, dog chain, your different hooks here. It's, you know, 1/4-20 hooks. The only thing that's a little bit out of the ordinary with this is this wire right here. Now, this isn't an ordinary wire. This is a piece of high resistance wire that whenever you run a current through it, it doesn't like to conduct it. Instead, it just heats up because it's inhibiting the electrical flow. Whenever I first started building one of these, they said to get a piece of nichrome wire, heating element wire. Nichrome is what's used in toaster elements, hair dryer elements, little space heaters. It's all nichrome wire. Well, I got to thinking about it, and I thought, okay, so nichrome wire is high nickel and chromium, so where else do you find high nickel and chromium? And that would be stainless steel. So I happen to have a whole spool of stainless steel wire because I weld it anyway. So I substituted stainless steel wire because it is technically a form of nickel chromium wire. That's what I used here. So you can find stainless steel welding wire in different hardware stores, and it works very well. The way you use one of these things is you hook up a power source to each end of this wire to heat it up. Now what you do is you connect one side. I'll show you here. I don't have the power source plugged in, but you clamp one side, your power source, to that side, and then you have another side plugged in over on this end, like that. Now, I have a run-of-the-mill battery charger here. The only problem with this is you need some way to control the heat through this wire. You can't just hook up each side because if you have enough amperage in a full battery, what ends up happening is you might actually turn this wire red hot. So what I realized was, being this is nichrome and it's high resistance, basically what you have here is one large resistor. So what I did was I ran another pigtail of this stainless steel wire for a couple feet, and then I started connecting the electricity at different points on here. And as I slid, I'll show you here, I hooked this side up to the power source, and what I found was as I slid this alligator clamp down a little bit further and further each time, what happened is it increased the amperage flow through this wire, and it got hotter and hotter. And you can see that on the battery charger whenever I actually plug this thing in. But what will happen is this actually acts as a variable resistor, and you can control your heat setting very closely just using this homemade resistor, so that you don't need a trained controller, you don't need a regulated bench power supply. All you need is that piece of stainless steel. And this is the one thing about this design that diverts from any other hot wire design I've ever seen, is they always use a power supply, like I told you, a variable power supply, but I modified it just to make it this much more easy, because why make it more complicated and expensive than you have to? Okay, so let's plug this thing in here and I'll show you exactly what I mean. I'm going to show you. You can hear that wire is under a lot of tension. Of course, that's necessary. When you're cutting a large piece of foam, this will start to bend like a bowstring a little bit, but it's pretty tight. Okay, I've got the positive and negative hooked up. It doesn't matter which end is which. For the sake of consistency, I'll keep red with red and put the negative side over here. And I'll plug in this battery charger. Okay, now it's reading 0 amps. So let's put it up here at the topmost point. We're pulling about, it started out at about 4 3/4 amps according to the battery charger, and as the wire heats up, it changes the resistance somewhat, and now it's down to a little over 4 amps. Let's see how hot this is. See, it's not cutting very quickly. You get a lot of pull on that wire. That wouldn't be good for a large piece of foam. Say if, like something like this, you cut out a 3-foot wing section, you want it to be able to maintain an accurate path all the way through the piece of foam, because if it doesn't, it'll start making the middle of a curve hourglass shape. So that's not hot enough. Let's move this, let's slide this down here a little bit. Now you gotta be careful because this wire gets hot too on the downwind side. Slide it to about the middle. Now we're reading 4.5 amps. So it should be getting a little bit hotter. Not so you can really tell, but it is getting somewhat hotter. Okay. Yeah, it's pulling way too much yet. So I'm going to turn the amperage up here a little bit more. Maybe bring it down here around 5 amps. Now you see it's starting to smoke. Let's try it again. Now you see the difference there? So let's put it clear down here once. See what it does. Big difference there. See how fast that cuts? So we're pulling a little over 5 amps now. So let's cut this piece here, see how well it works. You see it cutting through there pretty good. You can hear it hissing. And as it leaves off the trailing edge, it leaves off those long hairs on there. That's a characteristic that it's hot enough. Now, one of the things you don't want to do, you know, if you're making this wire too hot, well, one is if it's glowing orange, of course. But the other characteristic is if whenever it's cutting through here, it starts melting a gap, a real wide gap in it, then you know it's running too hot. And you can cut out all kinds of complex forms using something like this. I'm just going to do a wave pattern here so you can see how intricate this cutter is. Now when you do something like this, you don't want to do this in the house because this styrofoam stinks pretty bad when you're cutting it. Now it's not acutely toxic like some foams. The one thing you don't want to do is to cut polyurethane foam because apparently it makes cyanide gas, and I heard that's really bad for you. So you don't want to cut anything other than polystyrene with one of these things. So I'm going to cut that off. To show you here the kind of complex forms you can cut. See how it cuts that wave pattern in there. So these things are kind of neat to mess around with. If you have a pattern, I mean, you can make a vertical model of these, and I'll probably make another video of this. You can make a vertical model, so it's just like a bandsaw, really. Okay, now that you've seen the principle of operation behind this thing, let's go ahead and actually make something out of this that you could use. So I'm going to come up with a design, cut out a template, attach it to the end of the foam, and cut it out. One of the best things you can use for a template is a piece of Formica, like the countertop material that they glue down. I don't think I have a Formica here right now, but what I do have is some 1/8 inch aviation grade plywood left over, and I'll cut it out of that, and that should be a good substitute, but it's more expensive than Formica, so that being said, use what you have, but Formica is probably the easiest thing to get from Lowe's or Home Depot. So here's what I come up with. This is a USA 35B airfoil. This is the same airfoil that they used on the Piper Cubs, the J3 Piper Cubs. Now there's no particular reason or characteristic why I picked this. I just picked it out of a hat basically just to demonstrate this hot wire cutter and what it can do. But I'm going to cut out a 2-foot section of this, I think, right now, and use it as a center section for center wing section for a model aircraft or a glider or something here, maybe for a future video. At this point, what I'll do is I'll transfer this pattern onto a piece of plywood, cut it out with a scroll saw, sand it, and attach it to the end of the foam and cut this out. One of the things you have to keep in mind with the hot wire is you don't want any jagged edges. You want to make sure everything's really smooth here. It doesn't have to be real fine grit sandpaper, but as long as there's no edges sticking up to catch the wire. And so one thing that I do is I just put a slight radius or chamfer on the sides here. Okay, next thing I'm going to do is I'm going to put registration lines on this template. And so I've put some attachment holes in here for number 4 wire brads, and I've attached these to one another at this point. Now when I say registration lines, what I mean is I'm going to put in station locations, regular intervals, say every inch or so along here. And the purpose of that is very simple. Whenever you're foam cutting, your hot wire cutting over a longer span, say 2 feet or even 1 foot, you can get ahead of yourself on the left or the right hand side with the wire. So what happens is if the wire on the left hand side meets up with one of these registration lines, you want to immediately look to the right hand side and see if you're matching up with the line on the right hand side. If you're not, you need to kind of speed up your cutting feed on one side or the other depending on where the location of the wire is. So I'm going to quickly mark them on there. It's also a good idea to put numbers on the foam at certain intervals, so just so you know what line you're at. And if you have 2 people doing an operation like this, you have one guy on one side of the foam and another person, you can call out the actual registration lines to one another just to make sure that you're lined up. I found a piece of insulation laying around, and I was able to cut out a piece 2 foot 10 inches, which is what the cord length is here, 10 inches, and this is 2 feet long, which is what I wanted. This piece has been laying around quite a while and it's pretty beat up, but for our purposes here for demonstration, it's no big deal. Now the one thing I do too is I mark the front position here. Now I want to make sure that the nose, the leading edge of this airfoil, is at a certain height on here. Now it can be any height that I choose, but once I establish that height, I want to measure from one edge down or up and establish a dimension, and then that way I can mark it on the other side, and so the nose will match the same height on the other side. Otherwise what you'll end up with is a twisted, like when you put them together at the end, they'll be twisted like that or like that. And in some cases you want that. depending on what your goal is. But in this case, I want these to be pretty much perfectly straight, so I'm going to take accurate measurements. So I marked this side right here, the position at 1 1/16 of an inch down from the top edge, because I want those leading edges to be exactly the same on both sides. Let's go ahead and attach this one now. Get everything where we want it. And put a couple nails in here. And you push that nail in there as straight as you possibly can so it doesn't veer off into the path of the cutting wire. And then I do the same thing. This is really tricky back here, getting this wire in here perfectly straight, or as straight as humanly possible. Okay, now we have the airfoil template attached to one side temporarily. Now we'll take a measurement from the top here. This is a little trickier because I have to line up both sides before I can even put one nail in. Now the other things you have to do is you got to keep in mind whenever you're making a two-sided form, like you got to cut one side, then you have detail on the other side, it's best not to try to tackle the whole thing at once. You kind of want to do one side then the other. That's the easiest way of doing it. So what I'm going to do here, right at this location where I marked down for the leading edge, the outermost point of the radius, I'll put a nail right there in front of the leading edge, and I'm going to do the same thing over here. What that will do is your wire comes off, the wire will come off the leading edge and then hit these two nails, and it'll just come off the side there. And then that way you can do two halves, and then you can trim up the front radius whenever you need to. And do the same thing back here. Okay, we are ready now at this point to cut this out of cut this with the wire cutter. And the last thing I'm going to do is I'm going to support this a little bit higher and put some weight on it so that whenever it's cutting it doesn't move around. Now one other thing before I start cutting out this form is I was going to mention, if this was an actual wing section for an aircraft, you wouldn't do it quite like this. The template wouldn't be like this. What it would actually look like is, as it come back here, as you approach the trailing edge, you would actually come off and cut something like that. You cut it thicker, maybe not that thick, but maybe something like that. You'd want to leave the trailing edge thick on it, and the reason for that is whenever you're hot wire cutting, what happens is the heat from the hot wire sometimes distorts thinner sections of foam. I'm not going to worry about it here for demonstration purposes, but if it was a real aircraft wing, what you would do is you would cut out the entire form. You cut out the form, bottom and top, and leave it thick back here. And go ahead and do your sanding on the bottom and part of the top, and then you would fiberglass. You put a fiberglass layer on the bottom to support the bottom of the wing surface. Then after that, what you would do is you'd go ahead and either hot wire foam off the rest of this part here, if you could, if the fiberglass isn't in the way, or you just sand that part down to where it meets the fiberglass. That's the proper way to do it. I realize I'm kind of drifting off into aviation here on this video, but it's kind of the direction it went since I decided to use a form like this. So, but like I said, you can make anything out of foam that you want with this setup. And what you do is you set up some steel blocks around here, and that just keeps us moving, or from moving, when you're cutting with the hot wire. You need a little bit of friction there, and that's pretty good right there. I don't want to actually crush it. And here we go. Now you want to let the wire do the work. You don't want to pull on the wire too much and bow it, especially around the curve, because you'll cause an hourglass or belly, depending on what kind of radius it is, if it's convex or concave. And you don't want to do that, so you just want to let the wire do the work and let it cut at its own speed. Around 6 inches a minute is optimal, but see, I'm lagging a little bit behind on the left hand side, so I'm going to bring that into position. And hopefully the right hand side doesn't cut oversized too much. This takes some practice to get used to it. I'm pretty much lined up now. I led with the right hand side a little bit too much on that curve. Let's see how it worked. Let's check this out. Okay, I'm not going to take it apart yet. I'm going to go ahead and do the top side. Just going to flip it around. Bring that out. That. Hopefully it followed the template pretty well. Looks good. Oh, it stinks in here now. This stuff smells really bad. So let's see what it looks like. I got some striations in here where I lagged a little bit. Let's check this out. And you'll see here is an airfoil section, and I said about the trailing edge being distorted. For model uses, you'll look at that and I only probably have 20 thousandths distortion along this trailing edge here. So let's take these things off of here, these templates. Now where I put these nails in the front, you see there's a bit of, just a little bit of, I don't know what you call it, protrusion there, of course, where the wire comes out. Now what you do is just sand that off, and it's such a small area that it's no big deal. Like that, and there you have a very accurate form. Now these lines here, where I lagged a little bit, these can be sanded off. So hopefully if you have any distortions like that, they're sticking up instead of down in the foam. But if you cover this with fiberglass or fabric, there should be no problem. And this is readily sandable, this material. You should use a sanding block so it makes a nice smooth contour. That leading edge radius, kind of have to sculpt that and match it up with what you have here on your templates to make sure you don't distort it. Alright, I could continue sanding this thing and getting more of the high spots out, but that just gives you an idea of how you go about doing that. I sanded the leading edge radius down to where it's the same as on the templates, for the most part anyways. I might have missed a spot, but anyway, it just shows you what you can do with this hot wire cutter and the type of accuracy you can get out of this thing too. I'm getting very low distortion on the trailing edge too, which I'm real happy about. So if you're going to use this in a model airplane, say something that's under power, what I would probably do is I would cut a groove, and actually you can incorporate a groove right into your templates. But I would cut a groove in here and put a graphite arrow shaft in here to stiffen this wing so it doesn't snap in half when you're doing aerobatics. So if I was going to build this just as a glider, free throw glider, I probably wouldn't mess with that. I'd just leave it as is. This is pretty stiff material. So anyway, I hope you found that informative and realized that you can do complex things with very simple tools. This thing took me, I bet, maybe an hour to build at the most, cutting all the boards and drilling the holes and whatnot. But it didn't take a long time at all. And it's all hardware stuff, nothing exotic. So, like I said, I hope you found that informative. If you did, give it a thumbs up please, and subscribe to my channel also while you're at it, and I will be seeing you next video.